If you want to find surface defects on red-hot steel, you can't rely on manual inspectors or traditional vision. In this video, I'll explain how we have built an AI-based system that can detect critical defects on fast-moving red-hot steel profiles like rails, H-beams or other steel profiles. Imagine a rail like this, 900 degrees Celsius, 100 meter long, moving past you at 4 meters per second. It goes without saying that this can't be inspected manually, and if you must wait and do a manual inspection after the steel has cooled, you risk having rolled many defective rails before a potential problem is identified. Therefore, effective inspection requires machine vision, but traditional vision technology also fails short. The surface of steel that is cooling down has many surface variations that one might think are flaws, but are not, typically just glowing shells, which makes it very difficult to inspect based on contrast variations, which is what traditional vision technology usually does. The number of fault rejects would simply be too high. That is why we have introduced an AI-based solution for steel profile inspection, which can perform an inline inspection of the fast-moving profiles immediately after they have been rolled. The vision system is equipped with 6 or 7 cameras and lamps placed on a ring through which the steel profile passes. Due to the high temperatures, the cameras are placed approximately 1 meter from the hot steel behind a heat shield. The steel emits light waves in the form of heat. The heat and the light waves interfere with the image we need to capture, so we use optical filters that remove the light in the orange, red and near-infrared spectrum and make the rail appear as if it was cold. At the same time, we project very powerful white light onto the steel surface, which creates the shadows we use to detect the surface defects. A lot of light is needed because we must capture images with very short exposure times. In our rail inspection system, for example, the rail moves at 4,000 millimeters per second. As mentioned, steel that is cooling down has many contrasts on the surface, which makes it difficult to use traditional vision technology to find surface defects. However, the human eye can distinguish or classify the defects, and by training an AI model on a large number of annotated images, we have developed a neural network that can automate this process. The AI-based vision system works in 2 phases. First, we have an anomaly network that identifies the potential defects, and then a classification network that classifies the candidates. This could be wires, dents, cracks, or rolled-in scrap, and similar critical defects. It is important to accurately identify defect types because this gives the operator valuable insight into the production process and allows for necessary corrections to prevent recurring defects. So, with the help of skilled craftsmanship that ensures a robust system in an extreme production environment and AI-based inspection that makes it possible to classify defects on a tricky surface, it is possible to fully automate the inspection of red-hot steel.